So that's the kidney itself. Okay, so you can see that the red is the renal artery that comes in. That's going to have blood which contains glucose, urea, water and ions. And the renal vein which leaves is going to have all of those things, but then varying extents of ions and water. And it's going to have the urea taken out. Okay, both of them are not going to have any glucose. Okay, glucose is going to be ultrafiltrated, as we say, but it is not going to stay in the kidney nephron. So if we look at the nephron itself, we can see here that the red is the incoming blood. It comes to the glomerulus and it is ultrafiltrated into the Bowman's capsule. It's under pressure because you can see that the capillaries are all squashed in there in the Bowman's capsule, and that's a bit like an acorn sitting in its acorn cup. And then the yellow tube is the one that's going to have the glucose, water, ions and urea forced into it. That's based on size. Anything bigger can't get through. Two examples of things that couldn't get through are proteins and red blood cells. So they'll go along the yellow tubule and then they're going to be selectively reabsorbed. Do we want urea? No, so that's not going to be selectively reabsorbed. Do we want water? Yes, that is going to be selectively reabsorbed. The question is how much? We'll come to that in a minute. Do we want glucose? Yes, that's definitely going to be selectively reabsorbed. And do we want ions back in the body? Probably, and so they will be selectively reabsorbed to a certain amount. So, glucose definitely. How are we going to get glucose back? Well, if the concentration of glucose is greater in the nephron tubule in yellow there than the capillary blood surrounding them, then glucose will diffuse down a concentration gradient. Once it gets to about equal, though, it would stop diffusing and there would be like an equal net flow. So the body has to actively transport using energy the glucose from the nephron into the blood until it's all out. With ions, if we need ions, they might diffuse down a concentration gradient because there's more ions in the nephron than in the blood. But if we need to pull back extra, then they will be actively transported. And in terms of water, water is controlled by ADH. ADH is antidiuretic hormone, and that is released by the pituitary. If you are dehydrated and you need to pull more water back into your blood, and therefore produce a very concentrated urine, because you need to conserve water, then ADH is released and it affects the permeability of the nephron to water. The permeability will increase with ADH, and so water will come back into the blood. If we've drunk too much water, we've got excess water, and we want to get rid of it in our urine, then ADH release will be reduced by the pituitary, and that nephron will then become impermeable to water, or not as permeable, and therefore not as much water can go back into the blood, and the end result is it carries on through the nephron, through the yellow tube until it goes to the collecting duct, and urine is produced as a result of the urea being dissolved in the water.